Welcome and thank you for joining us today for this SPE Tech Talk with Hunting Energy Services. I'm your host for this broadcast, Joe Sinnott, coming to you live from Western Pennsylvania, which of course is known for steel and for unconventional horizontal wells. And all over the world, steel casing and unconventional wells go hand in hand, especially when it comes to the plug and perf process, which not only dictates the effectiveness of hydraulic fracturing, but also determines the overall efficiency, equipment utilization, and cycle times of unconventional oil and gas operations. Over the past decade, there have been several technological advancements in our industry that have allowed record-setting numbers of stages to be completed per day. However, variations in plug and perf processes due to labor inconsistencies still exist, and in turn, can negatively impact operational efficiency. We're joined today by Hunting Energy Services to discuss how integration of automated technologies available in plug and perf and in frac ops could further improve daily stage capacity. And if you want to improve today's broadcast, then please use the comment box to share your thoughts and your questions about today's topic. And our guest will answer as many of your questions as possible later on in the show. Please also let us know where you're watching from today and take a moment to answer today's audience poll question, which is, as a service company or operator, what would be your main concern with the idea of automating the perforating process? A, no concern. Automation is an improvement to the current manual method. B, perceived increased likelihood of off-depth perforation. C, perceived increased risk of a safety incident. D, lack of operator or industry acceptance. Or E, something else. Whatever your answer is, go ahead and use that comment box to give your answer and any additional color you'd like to share. And our guest and I will take a look at those answers later on in the show. And speaking of our guest, let's go ahead and introduce Adam Dyess, who is joining us today from Houston, Texas. Adam is Business Development Director with the Titan Division at Hunting, and he has over 15 years of experience in unconventional completions. Adam's current focus is on the IP portfolio, research and development projects, and collaborative partners. He is the inventor on 4 granted patents and a respected contributor to many industry publications, including SPE's Journal of Petroleum Technology. Adam holds an engineering degree from Vanderbilt University and an executive MBA from Rice University. Hello, Adam, and welcome to SPE Tech Talk.
Hello, Joe. Thanks for the introduction, and I appreciate SPE providing the platform to discuss today's topic.
Great. Well, we are happy to have you here, Adam. And if you would, to kick things off, can you give us an overview of autonomous plug and perf completions technology?
Absolutely. So if we look back at the past 15 years, the unconventional completion sector has seen a tremendous growth in daily stage capacity and operational efficiencies. This is primarily driven by processes and product innovation in the plug and perf space, which for this discussion includes both wireline and frac operations. So 20 plus stages per day is the new norm in several of the basins throughout North America. And if you were to visit any multi-well pad, you can see how various technologies have driven efficiencies and safety by eliminating human error and removing personnel from hazardous zones. So here are a few examples. At the top left is pictured the automated wireline lubricator to wellhead connection. So I'm sure many of the listeners have witnessed personnel having to go up in a man lift or even climb a frac tree and attempt to stab a swaying 50-foot lubricator stack onto the wellhead while the winds are blowing up to 30 miles an hour. So thankfully, technologies like this have not only removed these personnel from dangerous situations, but also significantly reduces the time to move wireline from wellhead to wellhead. On the top right, we have the simul-frac operations depicted, which involves multiple frac fleets and wireline units working simultaneously on a well pad. This process technology has revolutionized the plug and perf process, increasing stage capacity year over year for the past decade. And tied to the simul-frac is the automated valve control systems pictured at the bottom left. The typical plug and perf well completion sees thousands of individual valve turns. This technology allows digital, remote, and seamless well-to-well valve control for frac operations, which removes personnel from high-pressure, high-risk zones while also increasing productivity. And finally, pictured at the bottom right, we have an example of modular perforating systems, which now represent 90% of perforating guns run in unconventional wells today. These plug-and-play style guns are delivered by the manufacturer, which removes many of the human error failure points involved with assembling guns in the field, such as wire-to-wire connections and ported seals. Modular gun systems have been instrumental in mitigating misruns and non-productive time.
Great. So that's quite the evolution there over the last couple of years. But obviously, our industry, we're not ones to rest on our laurels, right, Adam? So
Right.
I guess looking forward to continue gaining efficiencies and building upon everything that you just described. What's the biggest obstacle to continuing to improve?
Yes, great question. Even with these advancements, there are still constraints in the overall plug-and-perf process that inhibit ideal utilization rates as the industry strives to reach 24-hour pumping. I was actually at an energy conference last month where several of the CEOs of the largest producers in North America were speaking, and the moderator asked the leaders what the biggest hurdle to operations were in 2022. And the common response was that the labor force in the service sector had led to stagnant operational efficiencies. And what he was referring to it was the current status of the labor shortage, the high turnover rate, and the inexperience we have on these well sites. So the labor issue has generated huge inconsistencies in service operations, which we all know is a recipe for quality issues and downtime. So the question is, how can we mitigate the effect of labor constraints on operational efficiencies? And I believe as a collective industry, which includes the producers, the service companies, and the product companies, we must address the variabilities inherent to manual processes by advancing automation.
Got it. So you mentioned variability, right? So, in the manual plug and perf process, there continues to be variability, right? So what of those variabilities haven't yet been addressed with automation? We talk about automation, there's a lot of promise, but what are some of the carrots that are still dangling out there in terms of those manual processes, those variable processes that are for the taking, if you will?
Right. Absolutely. For plug and perf in particular, very little has changed inside of the wireline unit where several manual activities take place. So if you look at the image here, you can see the wireline technician's point of view during a plug and perf process. And as you can see, there are several pieces of equipment that require manual operation, including the winch control, the shooting panel, and computers to run the acquisition software and downhole switch commands. So we can walk through a stage activity. So typically the wireline technician is responsible for manning the winch to lower and retrieve the tool string into and out of the wellbore. Now during the pump down into the horizontal, the technician is also communicating with the pump truck, sometimes via radio, to ensure that the pump rate and line tension are in sync during the pump down to bottom. Once at the bottom, the plug set and subsequent perforating process can begin. So the technician will start a perforating log in the acquisition software. They'll then move to the winch controls and start pulling up the tool string from downhole to each shot depth. And then they'll move their attention back to the switch software to communicate with the switches in each of the perforating guns. All at the same time, they'll be checking and rechecking the shot sheet to make sure that they are approaching the correct depth. Then they'll move back to the switch software to command and arm the downhole device. Then finally, once shot depth is reached, the technician will physically handle the shooting power supply and send voltage to the downhole gun or plug setting tool. And then after this, they'll actually write down the actual shot depth on their shot sheet. So these back and forth processes are very manual and they're repeated until the entire stage is completed. They're done under intense pressure with typically a company man pushing for faster operations. Combined with the long shifts and the repetitive tasks, this inevitably leads to human mistakes, which can cause a misfire or misrun and subsequent downtime. So there's an opportunity to combine and automate several of the previously described processes.
Got it. Well, so Adam, thank you for just, again, you gave a great summary of all the different steps that are involved. And I think it's a good time to remind our audience that there's several different steps involved in these tech talks, one of which is asking questions, sharing your comments so that Adam can address them later on in the show. So take advantage of this opportunity to chime in with your thoughts, with your questions, with your skepticisms that everything that Adam just laid out there can indeed be automated. So with that being said, and coming back to you, Adam, so you just laid all those out. So let's shift towards the solutions, if you will, the technology. So can you talk about some of the new, software integrated perforating technology that's been recently introduced to start addressing some of those opportunities that you just laid out for us?
Certainly. We recently launched a software-driven shooting power supply that's integrated with data acquisition and the switch controls all into a single panel. And this way, the entire perforating process is automated, expedited, and hands-free. So the wireline stage parameters can be uploaded into the system prior to or during the trip and well. And once pumped down the bottom, the technician can simply push a software button to start the automated perforating process. They can then handle the winch and monitor the other activities. There's no need to move back and forth between the various panels, software controls, and shot sheet. The autonomous system will check your switches, arm the guns, calculate the winch speed, and fire precisely on depth while pulling out of hole without any manual input from the user. The panel has standard perforating data acquisition on board, so it can log the data channels such as depth, CCL, current and voltage, line tension, and speed. And this eliminates the excess hardware in the wireline unit and allows for much needed system communication. So since the shooting power supply links with the data acquisition, the panel can automatically log and annotate perforation depths on the log record, which eliminates the manual shot sheet confirmation. The real-time shot verification, as well as the other various surface and downhole data channels, are also available to stream onto remote monitoring dashboards. This step change technology eliminates several of the failure modes caused by human error, such as shooting the wrong gun or off-depth perforations, overpowering and damaging downhole electronics, and unintentional initiations due to inadvertent power supply. The automated perforating panel covers the perf process, but it can also be combined with existing automation in other arenas in unconventional completions. So the perforating panel calculates the ideal winch speed, which can then be communicated in real time to existing automated winch controllers. So this means the technician in the wireline unit not only doesn't have to focus on the perforating equipment, they could also be hands-off on the winch itself. And so it's just monitoring all the activities rather than handling any equipment. There are also several service companies that have automated pump down units, which combine the pump controller for pumping the tool string to bottom with the winch controller so that line tension, pump rate, and line speed are all optimized during the critical pump down operation. The automated perforating panel would be an ideal plug-in to these existing systems.
So you covered a lot of benefits there when it, as it relates to the plug and perf side of things. What about on the frac side? I mean, does technology, as we shift over to the actual, frac side of operations, what are some of the tie-ins there? What are some of the potential benefits that you see and that the operators would expect from implementation of this technology?
Right, great question. On the frac side, automation is already very abundant. You have your digital lockout tagout systems, you have the digital well-to-well handshakes and valve controls like we previously discussed. And these innovations are all required to optimize simul-frac operations. And as around-the-clock pumping becomes more and more possible with these sort of technologies, we have to keep in mind that frac follows the wireline. So there is an interdependency there that relies on wireline to be consistent. It is feasible for these automated digital valve controllers utilized by frac to communicate with the perforating system and the winch controller previously described, such that the entire stage operation is seamlessly integrated. This would allow for 24-hour pumping operations to be realized because the wireline and frac would never be waiting on each other. Now you can throw in machine learning into the mix for real-time adjustments and improvements on the fly, and one can imagine even further increases in daily stage capacity.
Great. All right. Well, again, Adam, you just laid out over the last, almost 15 minutes, a whole bunch of benefits, which I think is a good time to revisit our poll question, right? Because I think we asked for, what hesitations people might have, thinking about automation. So again, we asked whether you're on the service company side or the operator side, what would be your main concern with everything that Adam just laid out there? So we asked again, A, no concern, B, perceived increased likelihood of off-depth perforation, perceived increased risk of a safety incident, lack of operator, industry acceptance, or other. And, it looks like we have a mix of different answers. We had a couple there for B, a couple for D. Somebody said safety again. So I guess let me ask you, what are you hearing? What do you expect to see, from a poll like that, Adam, based on your experience and your interactions with both, again, service companies and operators?
Right. I think safety will always be a big hesitancy in the minds of those moving to automation. But we all must remember that plug-and-perf explosive operations, that involves fallible humans performing the same activities over and over again under stress and sometimes with little sleep. And these are all factors conducive to complacency, which leads to safety incidents. And moreover, case studies have shown that most surface incidents do occur after a misrun. So this means that reliability and safety are interdependent. So I believe that automating out as many human interactive processes as possible can only benefit safety at the well site.
Got it. All right. Well, again, safety is going to get the attention of most people. So again, I think that might address some skeptics out there, but nothing, I think, addresses skeptical concerns, et cetera, than results. So can you talk about field results? Is this out there in the field? If so, what are you seeing? What is the feedback that you're getting from implementing these things, out in the real world, so to speak?
Yes, we've launched so far 5 automated perforating panels into the field, and they've been active for 5 to 6 months now. Customers are utilizing the automated features, so they're doing automated perforating throughout all of the stages, and they've done so with 0 off-depth perforation so far. The main feedback that we're receiving is that the automation allows the wireline technician in the unit to concentrate on monitoring the operations rather than to always moving around between the different multitasking operations inside of the panel with the shooting panel and the software and the winch controls. So the main feedback is just being able to focus on monitoring.
Great. All right. We do have a question here that came in from Energy Stream. OLR on Energy Stream asked, does this automated system avoid collars during plug setting and shooting operations?
So the system does not detect collars, no. But basically when you input the job program prior to your run and hole, the depths that you plan on perforating at will have to be tied back to your pipe tally to ensure that no collars are actually on the shot depths.
Got it. All right. Well, thank you for that answer. Thank you, of course, for the question. Continue to encourage our audience to ask away. Again, the beauty of this live broadcast is that we'll get to as many of your questions and comments as possible before we wrap things up. But for now, we still got plenty of time. And I have another question for you, Adam, and that is about data. So, you have the data from this automated perforating system. How does it, assuming it does, flow to wherever for remote decisions, remote monitoring, remote analytics? How does that, data flow, so to speak, work?
Absolutely. Big data is the key right now. So the software which runs the automated panel allows for all of the data channels from surface and downhole, like depth, line tension, line speed, CCL, plus the actual shot depth. Those are all captured and they can be available for streaming through third-party interface for remote viewing and dashboards. And one thing I want to emphasize is that actual shot depth. So previously, that's really a manual entry that's given to, it's an input that's by the user after each shot. Because we're integrating the panel with that data acquisition, that is automatically logged and denoted in the system and can be available for streaming.
Got it. Thanks. So the flow of data, I kind of like how you answered that question, because I'm looking here at one of the responses we got to the poll question from Chad Thames. So he said A, but he gave a little color. He said, still concerned that most of the progress is still automating individual operations, for example, perforating, and still a lack of orchestration across all of the operations and workflows. So again, you touched on the flow of data to help, kind of keep pulse on things, but any additional comments to some of the color that, again, I appreciate Chad adding to his poll question response there.
No, it's a great question. And it is true. A lot of these different automated systems are isolated for different operations. And all I can say is that one thing I like to resonate for this discussion is these technologies exist today. Some are in their infant stages, some are fully commercialized, and it really relies on, all 3 stakeholders, the operating companies, the service companies, and the products companies to continue to discuss, collaborate, and innovate to advance this automation forward.
Got it. All right. Well, you just said something there in your response. You talked about, still being in the infant stages, right? So I guess let me ask you, could you look into your crystal ball and say, what is the long-term potential? Where do you see things headed with, automation and this technology as it relates to, completions operations, Adam?
Right. So one can envision full plug-and-perf automation, 24-hour pumping, collaboration between all the stakeholders that I previously described. So ideally, you can have compatible controllers or a single controller utilizing machine learning AI to automate the frac valves, the winch controls, the pump down unit, shooting panel, data acquisition, everything on one platform so that all the plug and perf processes are seamlessly working together and that the operational efficiency and the utilization is near max capacity.
Got it. So I guess in terms of operational efficiency, a lot of people think operational efficiency, it's obviously time is a big piece, but also head count. So, talk to me a little bit about, sort of the head count efficiencies. Is that a goal? Is reducing head count on location, an objective of all the automation and the technology that we're talking about today, Adam?
Right. So, headcount reduction is not a primary goal, and I actually don't think it's necessarily possible with just the automated perforating panel. For plug and perf or the wireline side, you're always going to need the wireline technician in the unit monitoring operations, and then 2 to 3 personnel outside the unit maintaining equipment, getting ready for the next run. So the main goal in automation in this application is to remove the human interaction inside the wireline unit so that they can focus on, the operations as opposed to high stress multitasking. However, one can envision if you have combined the winch control, the pump control, and the perforating into a single unit, then multiple roles could definitely be combined and reduce headcount.
Which obviously comes back to safety, which you mentioned earlier. So I want to dig into a little bit more maybe on safety, particularly as it relates to, again, explosives. We're dealing with, some dangerous stuff there on location. So I guess in layman's terms, if somebody said, hey, I heard what you said about safety and yeah, there's a lot of implications here that have potential, but at the end of the day, turning over perforating to a computer, for lack of a better term, comes with some consideration. So Adam, any additional comments on that particular aspect of safety here as it relates to automated plug and perf?
Yes, definitely. I do understand there'll be some skeptics in that arena. And again, we just go back to what leads to most of the safety instances today, and that is typically human error and misruns. So typically any sort of surface incident involves a human doing something they should not be doing, or they don't realize that they're doing, and usually after a misrun. So after they've gone down hole and have to come out because there's an error. So there's 2 things you're working with. One is humans, and one is reliability of equipment or processes. And I think automation meets both of those, or addresses both of those issues by removing the human aspect on the operation side of the perforating process. Not removing altogether, but removing their interaction with the software, as well as making the system more reliable. You can address both of those issues and reduce safety incidents.
Got it. All right. Well, we have another question that came in this one's from Justin. So Justin asks, does the panel require a trained extra hand out on location, or does the wireline engineer need to be trained on troubleshooting the automation panel? Any thoughts on Justin's question there? That's
a great question. So the software is very similar to what they're used to right now. The only difference is they wouldn't be actually clicking buttons like they're doing. So both on the acquisition side and on the switch control side, it's very similar to what they're doing right now. We've added a lot of automated troubleshooting into the system, so it's not going to give any errors unless it's actually repeatedly tried to avoid the issue itself inside of the software. But if an error does occur, so there is an actual issue downhole, it will stop the automation and return to manual mode. So the panel is not automation or nothing. It is automation is just a mode as one of the options for firing. It still has manual mode and typically like the operations they're doing right now.
Got it. So I guess whether it's in full automation mode or assisted mode or whatever you call them, I want to go back to what you said earlier about data, right? You said yourself, right? Big data is the thing, moving that data. Thoughts on machine learning? We actually have a question here from Richard. So he asked, could you please discuss how machine learning has helped the automation process, or again, maybe will help the automation process? Any thoughts on how to actually, how it's going to be leveraged moving forward, to the extent that, maybe it hasn't been leveraged yet, Adam?
Right. There's not much in the machine learning as far as the perforating side goes, but if we look at, say, the pump down operations, machine learning can definitely play a role in there. So learning on the fly We have, thousands of data points from pump down logs. So these automated pump down units, they can definitely use machine learning to optimize the pump down, so there are no issues between line speed, line tension, and your pump rate. And this can also lead to possibly using automated pump down without any sort of downhole surface tension or downhole tension tools. You could be using surface tension to do automation instead.
Got it. So I guess another question that I have, so, I mentioned in the intro, we're up here in southwestern Pennsylvania, in the Marcellus, the Utica. Obviously, we plug and perf all over the place. So I guess, are there ideal scenarios, situations? Are there ideal, parts of the world where this is a better fit than other fits, Adam?
I think that's a great question. I think it could be used really anywhere where existing unconventional perforations are going on for plug and perf, as well as some of the emerging countries where, China, Argentina, where we have unconventionals becoming more and more predominant. It's really a great step change for those moving from, the conventional style of perforating to unconventional to go straight to this, because it does decrease the learning curve. And as we talked about earlier, the workforce, the inexperience, the high turnover rate, I think automation and automating as many processes as possible can only help in that regard.
Got it. Thanks. So I guess with the assumption that, this has the potential to work all over the place, are there prerequisites for a given, company that wants to investigate this? What do they need to have in place, whether it's culturally or, technologically or whatever it is, to really take full advantage of the potential of everything you just described, Adam?
I would say really the only prerequisite would be experience in unconventional perforating. If they're already running, multi-stage well pads, plug and perf, addressable switch technology, then they're already doing this, exactly what we're talking about. We're just simply automating the processes. So I think the barrier to entry is very low, and it's really just a single panel, one piece of equipment that can be added to an existing wireline unit. So like I said, I think it's very easy and simple to implement, and we're available to, guide anyone that's interested.
Great. Well, that is all exciting. I think as the clock ticks down here, I think we have time for one more question, and we do have one from Mike. So Mike on Energy Stream asked, are the service companies purchasing the perf panels or operators purchasing for automation and having service companies use? Can you shed some light on that question from Mike?
Yes, the service companies are the customers for the Hunting is the products company. They would be the customer and the user. So the operator would see the benefits, but the service companies would be buying the equipment, adding it to their perforating units or their wireline units, and they would be actually servicing these wells.
Got it. All right. Well, thank you, Mike, for the question. Thank you, Adam, for the answer. And Adam, anything else you'd like to share for those out there that are either, interested in what they heard or that might, still be a little skeptical about the idea of automating these processes?
No, just again that, advancing this automation technology really involves collaboration and partnerships. So just want to continue the discussions. If anyone has any questions or would like to collaborate, you could reach out to myself, and we'd be happy to move this technology forward.
Awesome. All right. Well, the audience just heard your invitation to reach out to collaborate. So I guess let me ask, what's the best way for them to get a hold of you, Adam?
Yes. So you can have my email or LinkedIn. I believe they're both posted on the screen now.
Great. All right. Well, again, for those of you who are watching live or on replay, either way, if you have questions, ask Adam or continue asking them here on the platform, whether it's Energy Stream or LinkedIn, and try to get as many answers to your lingering questions as possible. Want to thank everybody in our audience who took the time to collaborate with us today, to ask questions, to add your comments. We always appreciate your interaction. And of course, again, thank you to Adam for giving really an overview, not just of the new technology, but really stepping through the evolution of plug and perf. So really appreciate your time today, Adam. Really appreciate you enlightening us on, the advancements in automation and plug and perf completions. And of course, want to give a big thank you to Hunting for making today's episode possible. With all of that being said, if you'd like to watch a replay of today's episode, you can do so by heading over to the SPE Energy Stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
The energy industry is evolving rapidly. To stay informed, you need relevant content available when and where it's convenient for you. Introducing the SPE Energy Stream, the energy sector's platform for quality content from around the world. Energy Stream gives you access to technical solutions, innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event presentations, this easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders, then save the videos that interest you so you can watch them at your convenience. Stay ahead of the curve. Start watching SPE Energy Stream today.